In this lecture, we will discuss about the fundamental theorem of arithmetic. First, we will see what are prime numbers and composite numbers because we will be using those numbers in this theorem. So, prime numbers are the numbers which have exactly two factors, 1 and the number itself. So, two factors, 1 and number itself. So some prime numbers, when we write, they are 2, 3, 5, 7, 11, 13 and so on. There are infinite prime numbers. And second is composite numbers. Composite numbers are the ones which have more than two factors. Means they come in the table of different numbers, or we can say they have more than two factors. For example, 4, 6, 8, 9, 10, 12 and so on. If you observe, the smallest prime number, which is the only even prime number, that is 2. All other prime numbers are odd numbers. And the composite numbers can be even or can be odd also. So here if we observe, the smallest composite number is 4, which is even composite number also, and the smallest odd composite number is 9. Now the fundamental theorem of arithmetic, when we discuss, it says that every composite number can be expressed as the product of the primes in a unique way. Maybe we can change the order, but the prime factors will be same. Before we come to discuss that, we come to one concept, that is, if we take any 2 primes or any 3 primes and when we multiply them, only taking as 1 power or 2 or 3 or many. For example, if I am taking 3 prime numbers and if I look at the combinations of the products of these primes, we can get infinite numbers. For example, the first case, if I simply multiply 2 into 3 into 5, this will be 30. Or if I take 2 square into 3 into 5 square, 5 square is 25, 25 into 4 is 100, 100 into 3 is 300. Like this, by taking these 3 prime numbers, when we multiply them in the different combinations, we can get infinite natural numbers or infinite positive integers. And the reverse of that, each natural number or each positive integer can be expressed as the product of the prime numbers. Means, if simple number like 9 I have taken, 9 is a natural number, positive integer, or the theorem says every composite number. Okay, so every composite number can be expressed as the product of the prime factors. Now the factors of 9 are 3 into 3. If we look at the factors of 12, it is 2 into 2 into 3. So the theorem says these prime factors are unique. It means that this number 9 can only be expressed as 3 into 3. There is no other prime number which will come in the product. Similarly for 12, if the prime factors are 2 into 2 into 3, there is no other prime number which will be included in the product. Maybe the order is different. For example, this order I can write as 2 into 3 into 2 or 3 into 2 into 2. Clear? What is different? The order. But the prime factors are same. So this is the fundamental theorem of arithmetic. Now fundamental theorem of arithmetic can be used in different concepts. First is to find the LCM and HCF of the numbers with prime factorization. Also, when we find the HCF and LCM, it will be used in one formula which says that the LCM and HCF of any two positive integers a and b. Suppose we are taking two numbers and the rule says the HCF of two numbers multiplied by LCM of those two numbers is equal to the product of the numbers, means a into b. So there are four quantities, two numbers, HCF and LCM. So before coming to this law, first we will discuss what is LCM. If we have to find out the LCM of any two numbers, then we first express that number or numbers in the form of its prime factors. Then we find the highest power of each prime factor and we multiply it, that is called the LCM. But in case of HCF, we find the prime factors and we choose the common factors and we multiply it. Or we may say we find the product of the smallest power of the common factors. So we have to first find the prime factors of each number whose HCF or LCM we have to calculate. After finding that, this rule also can be used to calculate. Suppose we know the LCM of two numbers. Okay, so we can find out the HCF by dividing the product with the LCM. Or if we want to find out the LCM, then product of the numbers divided upon HCF will give us LCM of the numbers. So this rule also can be used. So first we will discuss how to find out the prime factors, then we will find out the HCF, then we will find out the LCM, and we will work on this rule. So let's take one example to find the prime factors of any number. So first example is 140. The simple rule to find the prime factors, you just apply the divisibility test, and that depends. If you are checking with 2, check the units place. For 3, the sum of the digits, like that. Apply the divisibility test and then find out the prime factors of this number. This will be 70, 35, it will not go by 3, it will go by 5, 5 into 7, 7 into 1. So the prime factors of the number are 2 into 2 into 5 into 7. This is also, you can say, fundamental theorem of arithmetic. Every composite number can be expressed as the product of the prime factors, and those prime factors will be unique, means no other prime factor will come in this case, only the order can be changed. Okay, so like this we can find out the prime factors. Now we will discuss how to find out the HCF and LCM of numbers. Suppose the question is find out the prime factors and find out the HCF of two numbers. Numbers are 26 and 91. One thing we have to remember, whenever any two numbers, they don't have any common factor, it means those two numbers which don't have any common factor other than 1, they are called co-prime numbers. Okay, because their highest common factor is 1. So first we will see if the numbers are co-prime or not. If they are not co-prime, we will find out the prime factors. So here 26 comes in the table of 13 also, so it's a composite number. Okay, 91 also, it comes in the table of 7, so they are not co-prime. So we have to find out the HCF and LCM of these two numbers. So first what will we do? For HCF, we will find the prime factors of 26 and that we will write in front of the number. So 26 can be expressed as 2 into 13. Similarly, we will find out the prime factors of 91. Units place is 1, it will not be divisible by 2 and not by 3 also. So it is divisible by 7, 1 and 13. So 91 can be written as 7 into 13. As I said, the highest common factor is the minimum power of the common factor. Now common factor here is 13. So the HCF will be 13. We will write its HCF, that is 13. And LCM. LCM will be the highest power. So here 13 is repeated and its highest power is 1. So once 13 will be taken in consideration, and left out are 7 and 2. So they will also be considered because their highest power is 1 only. So the LCM will be 2 into 7 into 13. So if we have to find out the HCF or LCM by prime factorization, for HCF we will write separately the prime factors, choose the common factor. If it is 1, so that will be the HCF. If it is more than one common factor, so all the common factors will be multiplied. But if we are finding out the LCM, the common factor with the maximum power, suppose the number would have been here 13 square, so we would have taken 13 square in the LCM column. But here it is to the power 1, here also to the power 1, so once it will be taken, and left out the prime factors will also be taken in the product. So HCF is 13 and LCM will be 14 into 13. That is 13 4s are 52, 5, so 182. So what we have seen, HCF is the prime factors first of all we will find, and HCF we will calculate with the common factor, and if more than one common factor is there, product of that. And LCM we will take as the maximum power of the prime factors. So HCF is 13 and LCM is 182. Now in the same question, if it is asked to verify the formula what I give you, that is HCF into LCM is equal to product of numbers. So what we will do, first we will say that HCF into LCM, that we will find out LCM and HCF we will multiply, and we will also multiply 26 into 91, and on multiplying these two we will see the product will be same. Okay. There are some uses of fundamental theorem of arithmetic. There are some questions like prove that 6 to the power of n cannot end with 0. If any number ends with 0, the prime factors of that number should be 2s and 5s. For example, if I say 20, 20 can be written as 10 into 2 or 5 into 2 into 2. It means the prime factors are 2s and 5s. Then only it can end with 0. And if I simply say 20 to the power of n, so obviously the number of times we are multiplying this 20, definitely it will end with 0. So if any number which is given and it has to be proved it will not end with 0, the most important thing is its prime factors. So first let's see what are the prime factors of 6. The prime factors of 6 are 2 and 3. No matter whatever number of times 6 will be multiplied, it can never end with 0, because what is missing in this case is 5. And we can say if we are taking n is equal to any number, 5 times, 6 times, 10 times, 100 times. But if this 6 to the power of n cannot end with 0. So simply we have to write, since the prime factors of 6 are 2 and 3, so it cannot end with 0. Since if the prime factors are not 2s and 5s, it cannot end with 0. So the simple reason is we will find out the prime factors of the base. This question can be changed prove that 4 to the power of n, 12 to the power of n, or any other number to the power of n cannot end with 0. The only thing we have to write are the factors of this base. So here the factors of this base is 2 into 2. Here 12 can be written as 2 into 2 into 3. So 5 is missing. So whenever it is not in the form of 2's and 5's, the product, then it cannot end with 0. So this is the simple reason what we can write for these type of numbers.